Greetings to you. Welcome to Physics with Ben. In today's video, I want us to look at calculations in current electricity. I have promised to make a video on this. Click in the description box below and you'll see the video links to the theory, everything about Ohm's law, the calculation, Ohm's law, connection of resistors in series, in parallel, how to find the combined resistance. I've also done so many experiments on current electricity, verification of Ohm's law, the potentiometer experiment involving the standard resistor and the variable resistor, the resistance box, all of that in the description box below. So without wasting much time, I would like us to solve a very, very important question in this book. If you are with your textbook, I'm making use of New School Physics textbook, and get your calculator set with you and the pen and the paper beside you. Trust me. Today I was challenged by my colleague. He asked me to try question 16 of this book. If you are with this book, open to question book, page 408, question number 16. He asked me, Ben, I have solved a very difficult question. Can you please try it? Let me see if you are able to solve it. I tried it and I got the answer. I was so happy and excited. And I say, let me share the answer with you. I call this question a bonacious question. You know what that means? A bone you have to break. A bonacious question. You can't find that in the dictionary. Anyway, let's begin. I read. Explain why the E.m.F of a cell is greater than the Ph.D across the cell when it is passing a current through an external resistance. You can find that in your textbook and you answer. I want to go straight to the part B, second part of the question. A cell of E.m.F, E and internal resistance R was connected in series with two external resistors A and B of 4 ohm and 2.5 ohm respectively. When a high resistance voltmeter was connected across A, the reading was found to be 2 volts. Full stop. When another resistor of 4 ohm was connected in parallel to A and the voltmeter connected across A and B, the voltmeter reading reads 3 volts. Draw circuit diagrams of the two arrangements. Calculate the E.m.F and the internal resistance of the cell. So, let's begin. Solution. This is question number 16. Solution. The first things first we have to do in this question is for us to draw the circuit diagram. And I hope that's not very difficult. So there are two circuit diagrams we have to draw here, and we have to derive two equations, what I call word problem leading to simultaneous physical equation. In mathematics, you have it as word problem leading to quadratic equation, word problem leading to what? Simultaneous linear equation. So let's begin. A cell, this is diagram 1. I'm going to divide the board into 2 so that we be able to get this straight. I'll divide the board into 2. It will take me less than 15 minutes to solve this question. But because I'll be solving and I'll be explaining, it will take me a longer time. So I would love if you can stay with me to the end of this video so that I don't miss it out. So this is, instead we should draw 2 diagrams. This is diagram 1, and this is diagram of diagram 2. So this is a cell. This is a symbol for the cell. Yeah, plus and the negative. That cell has an internal resistance. This is the symbol for internal resistance of a cell. Small r is connected in series, and then the E.m.F.E is not given. It's connected in series with the weight and a resistor A with resistance 4 ohm. Good. And in series with another resistor B with resistance 2.5 ohm. Good. For this arrangement, the current will flow in this direction. This is the current we set it. It will flow this way, this way, this way. Then they ask us that when a high resistance voltmeter was connected across a resistor was connected across A, let's call it VA. And this VA, when it was connected, it gave us a reading of what? Across A, the reading was found to be what? 2 volts. This is the circuit diagram for the first arrangement. For the second arrangement, the circuit diagram is this. Now they say, when another resistor of 4 ohm was connected in parallel to A, and a voltmeter connected across A and B. So this is the information, the diagram for the second information. Stay with me. The same internal, the same cell, and this is E still not given. Then that resistance R plus negative, and was connected this time in parallel with A. So this is resistor A. This one was connected in parallel with A. With another resistor or resistor. This is, let's call it this is resistor. Let's call it C. Yeah, let's call it resistance C. And it was connected in parallel with A. And then this is resistor B. Then you have something like this. The current will flow in this direction. Is a current I, down, here, up, here, down, here, this way, up, down, this way, up, and back in here. So this is the direction of the current. Then, when that happens, another voltmeter was connected. Let's call this, this is VABC. This voltmeter was connected across the 3 resistors. Good. And it reads what? It reads 3 volts. So this is the circuit diagram for the whole of the arrangement. So with this, I've gotten the marks for that particular part of the question. Now, the next thing we are supposed to do, let me include, so A is still 4 ohm, B is still 2.5 ohm, and C is 4 ohm. Yeah, C is 4 ohm, A is 4 ohm, B is that, and that, this is that. So we are done with the circuit diagram. The next thing we have to look at is the actual to calculate. They have to calculate what? To calculate the internal resistance R is not given, and the E.m.F in the cell is not given. So there's a video I wanted to produce on internal resistance of a cell, but because of this video, I'll just make everything here quickly. The internal resistance of a cell is inversely proportional to the current in the circuit, or the current that the cell will produce. It means that if the internal resistance of a cell is very high, the current will be very, very low. So the equation for the internal resistance of a cell is given as I maximum is equals to E all over small r. All over small r. When you're seeing this in your physics textbook, so anytime the internal resistance of a cell is very high, the current will be very, very low in the circuit. Now, we are going to produce two basic equations here. There are two simultaneous equations here because this is what we have. Now, recall that there's what we call the lost voltage and the terminal potential difference. The lost voltage is simply the voltage across the external resistors, capital R. Like this one, we can say this is our R1, this is our R2. Here, this is our R1, this is our R2, and this is what our R3. So the symbol for the resistance, capital R, is called the external resistor. So the voltage across the external resistor are called terminal potential difference. Lovely. While the voltage across the internal resistance of the cell, small r, is called lost voltage. So here we have a small v. Here we also have what? A small v. The voltage across the internal resistance of the cell. Now, mind you, it is still this one cell that produces this particular circuit diagram. So the E.m.F here is going to be the same with the E.m.F here. And also, the internal resistance here is going to be the same thing with what? The internal resistance here. So for this particular circuit, we write that E is equals to V plus small v, where V is called terminal potential difference and small v is called the lost voltage in the circuit. Now, recall from Ohm's law that your V is equals to IR. So we are going to customize this equation to fit into this. Now, because these resistors they are in series, the same current will flow through them. So when that happens, we're going to have E is equals to I. Let's name this as our I1 because there are two circuit diagrams. So this is our I2. Very good. So say that our V is equals to what? It's equals to what? It's equals to I. Sorry, this is I2R plus what? I2 small r. But then this guy here is given. So say that our V is equals to what? It's equal to capital V plus what? I1, sorry, this is I1, sorry, this is I1 R. This is our V1 is equals to I1R. Call this equation number 1. So, what I mean here is that the total voltage in this circuit is this. The V1 is simply VA plus what? VB. We are still going to come back here and find the voltage across B. The voltage across B, we will look for that voltage. Trust me, the voltage across B, we will look for it later. So here, the equation here is this. We have our E is equals to, let's call this as our V2. This is our V2. And this V2 is the same thing as what? VABC. VABC. So this is V2 plus what? small v, the lost voltage. So if we write that from Ohm's law, we have our E is equals to V2 plus I2 small r. We call this equation number 2. We are going to make use of these two equations. So let's start solving with the first one. Before we find our, we know that our E is equals to V1 plus IR. Good. We're going to look for the current in the circuit, and that's our I1. From Ohm's law, we know that V is equals to IR. So we say that VA is equals to IRA. So this implies that our I is equals to VA all over RA, which means that, let me divide the board, which means this implies that this is I1. So this is I1 is equals to VA is 2. 2 divided by 4. That will give us 0.5. That will give us, we have 2 divided by 4, and that will give us 0.5 amps. We are going to come back to this equation later. So we have found that. So now that we have found our I, we're going to find the voltage across B, so that we'll now find our total voltage in the circuit. But because we need the value of V1 in this equation, so we'll say that VB is equals to IRB. So this implies that our VB is equals to 0.5. RB is what? RB is given as 2.5 times what? 2.5. If you do that, you'll be having that 0.5 times 2.5. That will give us 1.25. We have 1.25 volts. So our VB is equals to this. Our VB is equals to this. Now, our V1 is equals to VA plus what? VB. And if we do that, our VA is what? Our VA is 2. So we'll have to say 2 plus what? 1.25 all voltage. If you do that, that plus 2, that will give us 3.25. 3.25. So our V1 is simply 3.25 volts. Now that we have found our V1, let us move straight and also find, we have looked for V1, we have looked for what? For I1. So let's write this stuff here quickly. Our I1 is equals to 0.5. So if we come back here, we can say that the current in this circuit, I1 is 0.5. 0.5 amps. 0.5 amps. Our V1 is equals to 3.25 volts. Now let's come to this circuit. We want to find the total current in the circuit. But before we find our I2 in the circuit, we'll have to resolve these resistors and find the combined resistance. So we say that we have a 1 all over R1 plus 1 all over R2 plus what? R3. And it's equal to what? R total. So that R total is equal to 1 all over 4 plus 1 all over 4 plus what? 2.5. This is the same thing as 4, 1 plus 1 plus 2.5. Do that correctly, we'll have 2 over 4 plus 2.5. This means that our RT is equal to 4 over 2 plus 2.5. This is the same thing as 2 plus 2.5. So our RT is equal to 4.5 ohm. So The total resistance in the circuit is 4.5 ohm. So because of that, this is the terminal potential difference for the whole circuit. So set up from once to V is equals to IR. So this implies that V2 is equals to I2 times R total. So this implies that the current in the circuit, which is I2, is equals to what? V2 over R total. And that will be the same thing as what? V2 is this VBC. Take notes. VABC, the same thing as what? V2 in the circuit. So say that 3 divided by 4.5. So I2 in the circuit is simply what? It's simply 3 divided by 4.5. And that will give us 0.666 amps. So 0.666 amps. Lovely. 0.666 amps. So this is that for that. So in this circuit, we said that our I2 is what? 0.666 amps. 0.666 amps. Our E is yet to be known. Our E is yet to be known. Now, we'll have to come back to equation 1 and equation 2 quickly. I hope I can clean this. Yes. Let me clean this. Our I1 is this, our V1 is this. I can also clean this now. Yes. And then our I2 is 0.666 amps. And then our V2 is equal to 3 volts. Yes, our V2 is equal to 3 volts. So with this information, we are good to go. So let's rewrite. From equation number 1, we write that our E is equal to V1 plus I1 R. This is equation 1. Equation 2 says E is equal to V2 plus I2 R. Equation number 2. Now there's what I call the physics of cut and join and substitution, where you have to equate an equation with another equation to get a complex equation to solve a complex question. Lovely. So we are going to equate equation 2 with equation number 1. So this implies that V1 plus I1R is equal to what? V2 plus I2R. Call this equation number 3. So we are going to collect like terms. So this implies that V1 minus V2 is equal to what? I2R minus I1R. R is common here, so we factor small r out. So this implies that our V1 minus V2 is equal to R into what? I2 minus I1 all closed. So they ask us to find the internal resistance in the cell. So this implies that small r is equal to V1 minus V2 divided by I2 minus I1. All in volts, all in amps. So small r is equal to what? Let's input. Our V1 is what? 3. So we have 3.25 minus V2 is 3 minus 3. All in volts divided by I2. I2 is 0.666 minus I1 0.5. All in amps. So small r is equal to what? If you do this correctly, you're going to have, this is 0.25. Okay, then 3.25 minus 3. That will give 0.25. I said it. 0.25. all in volts, divide by 0.666 minus 0.5. That will give you 0.166 all in amps. If you do that, you have 0.25 divided by 0.1666. Sorry, 166. You're going to have 1.5. Therefore, the internal resistance for the two cells is given as what? 1.5 ohm. Lovely. So now that we have found the internal resistance in the cell, we can come back to equation 1 and equation 2 and solve for E. Either ways, we're going to have the same answer. So let's solve for the first circuit. We have E is given V1 plus I1R. So this implies that E is equal to what are V1? V1 is 3.25 plus I1. I1 is 0.5 times 0.5 times what? 1.5. So let's try it. We have 0.5 times 1.5. So we have 3.25 plus 0.75. That will give us 4. Let me confirm. 4. We have 3.25 plus 0.75. Exactly 4. Therefore, E in the first circuit is what? 4 volts. E in the first circuit is 4 volts. So right that here is what? 4 volts. Let's try for the second circuit. E here is given to be V2 plus I2R. Lovely. So this implies that E is given to be V2 is 3 plus I2. I2 is 0.666 times 1.5. So we have 0.666 times 1.5. That will give us we have 3 plus 0.999. So if you do that, you have 3 plus the answer. So our E, therefore our E is 3.999 volts. In the second circuit, we have our E to be 3.999. Approximately 4 volts. You see, I keep telling you, physics is not difficult. A round of applause for me. That is lovely. So this is the question. I promise to make more videos on current electricity. The reason why I take time to solve this step by step is because you are going to see a whole lot of questions on this in your external examination. I'll make more videos on in calculations in current electricity. To this, we have come to the end of today's video series. Don't forget to subscribe to my channel and then share this video to people that are very close to you who are doing physics. Don't forget to invite people to like my channel, to subscribe. God bless you. Stay safe. Bye-bye for now.